Okay, sorry guys, got a phone call and it stopped the video. Sadly, I didn't realize it for several minutes, but anyways, okay, we're back. So, we're talking about breaking ionic compounds down when they are solutes in order to dissolve them into a solution. So, I was talking about the fact that we have sodium chloride. It is an ionic compound. It's made up of sodium, which has a charge of +1 as an ion, and chlorine, which has a charge of -1 as an ion. So, what happens with an ionic compound is that, if you remember, water is a polar covalent compound. That means it has partial charges. And we learned 2 modules ago that that means that there is an attraction, right, toward the charges in ionic compounds. Because we're right, an ionic compound is made up of ions. So, in our polar covalent compound, we are able to dissolve other polar covalent compounds and ionic compounds. And the way it happens with an ionic compound is that the ionic compound is split up into its ions. Sodium has a charge of +1 as an ion. Chlorine has a charge of -1 as an ion. So up here in my little beaker, oh, it already did it. Well, that's okay. You can't see it that well anyways. Again, I didn't realize it had stopped videoing. So we've got sodium chloride, okay, sodium and chlorine ions. And what happens is that the water comes in with its partial charges and it's attracted to the ions of the sodium chloride, and it actually breaks those ions apart. Okay, what happens then is you have ions, sodium ions, that are now being broken apart from their chlorine ions, so now they're separate. And once they become separated from each other, they can freely move within my solvent. Okay, they're freely moving within my solvent, and once that happens, we say that it is dissolved. Okay? A dissolved solute is simply a substance that is freely moving within my solution. Okay? So we would write sodium chloride as my solute, H2O would be my solvent, and then salt water would be my solution. And we would write that NaCl aqueous. Okay, which that's what this, now remember we've talked about aqueous a little before. That's what this term means. It means that this solute has been dissolved in my solvent and my result is a solution. I have an aqueous saltwater solution. That's what that means. Okay, all right. So now let's talk about, that's how an ionic compound becomes dissolved. So one other key thing. So what's happened to this solute is that it has actually changed phase. Okay? It's changed phase and it is now liquid within my solution. Okay? Now, let's go back to a covalent compound. All right? In a covalent compound, it works a little differently. If you remember, we have talked about covalent compounds and how they break down. Ionic compounds break down into their constituent ions, sodium and chlorine. We have a covalent compound here, pH3, and what happens in order to dissolve a covalent compound is that the molecules of my covalent compound, which are obviously all close together, the water wedges in between them and it splits one molecule off from another. And then the same thing happens. These molecules are broken off individually, and then they are, just like the ionic molecules, then freely floating within my solution. Okay? So that's what happens with a covalent compound. With an ionic compound, the molecule, one NaCl molecule, can be broken apart into its constituent ions. Then it will be moving freely within my solvent, resulting in a solution. In a covalent compound, each pH3, this was made of pH3 molecules, each pH3 molecule will be separated from all the others, and it will then end up moving freely in my solvent, resulting in a pH3 solution. Okay? So that's how chemically, okay, a molecule, be it ionic or covalent, becomes dissolved as a solute into a solvent. Now, does that mean that water can dissolve any ionic compound or any polar covalent compound? No, it doesn't. Okay? In order for those water molecules to dissolve the polar covalent compound, it has to have enough charge to break the ionic compound apart or to pull one of the pH3 or whatever covalent molecule away from the others. Okay? This is going to go back to our periodic properties. Okay, and so not every solute will be able to be dissolved in water. It's going to depend on the actual chemical makeup of that solvent and that solute. Okay, if we have a substance that cannot be dissolved, the term we use is insoluble. We talk about the fact that if we could have a substance that cannot be dissolved, say in water, we would say that solute is insoluble in water, meaning not able to be dissolved in water. Okay? Doesn't mean it can't be dissolved in something else. It simply means that solute has an identity which cannot be dissolved in that solvent. Okay? So, let's do a quick just overview of that again. Similarities and differences between ionic and polar covalent dissolvings. In both compounds, the H2O molecules are going to be attracted to charges that exist in the compounds or in the ions. And in both compounds, a phase change occurs because the water molecules are able to surround the molecules of the substance and break them apart. In ionic compounds, it breaks them into individual ions. In polar covalent compounds, they're broken into individual molecules. Okay? I'm going to take a break, come back, rewrite the board, and we'll go again.